Good morning. This is the first lecture of a 50 lecture course on heterocyclic chemistry, what I plan to complete in a semester, and all of you know the heterocyclic chemistry is a very important topic. It is a subdiscipline of organic chemistry, and it covers more than 50 million of organic compounds, 50 million, 15 to 10 to the power 6 organic compounds registered today in the chemical literature. So, it is not a very easy task, it is a very difficult task to cover the chemistry of 50 million chemical compounds. But what I will do, of course, I will refer you to a set of standard textbooks with most updated references, and occasionally I will do refer you also to some review articles and research papers. And to begin with, what I will do, talk about definition of heterocyclic compounds, and then we will go to the history little bit, then the utility of the heterocyclic compounds in our day to day life, and then of course, the course structures and what sort of topics I would cover, or the when I say structure means it is unlike the regular textbooks. What I will have something like topic organizations according to my opinion, and then of course, I will give towards the end I will talk about the grading systems for the course, and lastly an assignment for the next class. Okay. So, let us come to the definitions. All of you know the definition of heterocyclic compounds or heterocyclic compounds or heterocycles is that they are organic compounds, cyclic organic compounds in which one of the constituent members should be heteroatom, in which one of the constituent member of the cycle is in heteroatom. So, that is the definition. So, I think I do not have to give an illustration, but then the question arises, what is an heteroatom? That is important thing. You have to be little very careful about it. What is an heteroatom? How do you define it? Well, previously I used to basically take you to the right top corner of the periodic table. If you go to the right top corner of the periodic table, you will find all the elements on the right hand side of carbon should be considered as the heteroatoms. But then you have to forget about helium, argon, neon, all these things, right. So, what should be the two definitions? Then there are people who have defined heteroatoms like saying that the nonmetals which are more electronegative or as electronegative as carbon should be considered as the heteroatoms. But according to me, I think the best definition would be all these nonmetals having lone pair of electrons. I guess that would be a better definition, right. Heteroatoms should be those atoms in the periodic table or nonmetals which are nonmetals and having a lone pair of electrons. So, that takes care of most of the heteroatoms what we consider them heteroatom, like nitrogen, oxygen, sulfur, selenium, all these halogens, they are heteroatoms. And but for practical purposes, I think all of us know what are the heteroatoms. For practical purposes, the heteroatoms is oxygen, nitrogen and sulfur, and in organic chemistry domains of course is extended towards sometimes to phosphorus, sometimes to selenium. So, that means primarily this, and then of course, phosphorus and selenium may be included depending on the situations and time. Let me take a molecule which is my favorite molecule, in fact. Many of you must have heard this name of this molecule is known as colchicine. Colchicine, have you heard of colchicine? Colchicine is a molecule, okay. It has a benzene ring, then it has a 7 member ring up here, then one more 7 member ring, and with double bonds here and there. Then this is OMe, and then NH, OAC you see here, and then there are 3 more OMe groups. These are these. Okay. And why did I write? Just to clarify some of the things. For example, this is natural products though. It is a natural products obtained from a small kind of a flowery plant, and it is today, all of you know, it is used as an anti-gout agent. This was approved in 2009 as a very powerful anti-gout agent and natural products. Now, the question is, can we call this a heterocyclic molecule? Colchicine, I would say it should be classified as alkaloids, because it is naturally occurring, it exerts physiological activities, and it has a basic nitrogen that is this one, but it cannot be considered as a heterocyclic because it does not belong to the ring. So, nitrogen must be a constituent member of the ring system. So, that means it is not a heterocyclic molecule. Let me take up another very commonly occurring molecules. I think many of you know what it is. So, you take a 6 membered ring here, and then OH and OH, and all of you know what it is. It is glucose. Now, by definition, would you call it a heterocycle? But see, the very first definition of what I say, heterocycles are these organic cyclic molecules in which one of the constituent member of the ring system, ring atoms should be a heteroatom. Then I have defined also the heteroatoms. So, according to this definition, then this must be considered as a heterocycle, but there is a but means see glucose, carbohydrate, they are so prominent as glucose and carbohydrates, means because of the presence of the so many hydroxy group here and there, they distinguish themselves as a separate class of organic compounds. So, for convenience sake, we do not consider them as the heterocycle. I mean, arguably yes, it is heterocycle, but for normal practical classifications we do not consider them. Let me take you to another molecule. I think all of you know what it is. It is a cyclic anhydride. So, is it a heterocyclic molecule? This is glutadic anhydride. Well, according to the definition it is yes, but we do not consider it heterocyclic, because they are chemical properties as anhydride overshadow the properties of the heterocyclic molecules. When I say properties of the heterocyclic molecules, I think they would be considered in the next class. Okay. Then let us say there are molecules of this kind, right, all of you know. So, what is this molecule? This is molecule, right? Anybody knows what is this? Adenosine. Adenine. Sorry, adenine. Okay, adenine. So, adenine is it a heterocyclic molecule? Is it a heterocyclic molecule? Well, again, according to the definition, yes, but it is more prominent in the literature as nucleobase, because they occur in RNA, DNA, and they can pair up, right. That is their important property. They can pair up to form double helix and all these things. So, essentially, although they are considered to be heterocycles, but for practical purposes they are not considered to be heterocycles. So, they are basically these nucleobases. That means, as nucleobases they are prominent in the chemical literature. So, we can ignore them. That means, most of the heterocyclic books would not would not rather discuss much about this. I mean, they will just touch upon and do little bit of the chemistry of the preparations and little bit of the properties, that is it. Okay. So, let us look. So, these are the best, that means now the definition is clear, right. Also there is one more important thing, like say when we talked, when we studied heterocyclic chemistry in 1970s, if you go to the Finner's book, that is the standard textbook of organic chemistry, they would only cover under heterocyclic chemistry only aromatic heterocyclic compounds. In those days, aliphatic heterocyclic compounds were not considered to be the heterocycles. Okay. But today again the same classification has come back. This, I mean actually this was proposed by a scientist, I have forgot a scientist named Albert. He proposed that the heterocyclic compounds should cover both aliphatic heterocyclic and aromatic heterocyclic. So, in fact, they classified all these heterocyclic compounds into two groups first, aliphatic and aromatic heterocyclics. Okay. So, that means although the proposal was done in 1953, but today it has been accepted. Okay. And let us look at a molecule I think some of you should be familiar with. Once again, this is this early history of heterocycles, is a purine nucleus, and what you can see here, this is nucleus. This molecule was discovered in 1818, it is easy to remember 18 and 18 long back, and then if you oxidize normally with nitric acid or chromic acid, what do you expect? You expect a molecule of this kind. So, oxidation takes place at the double bond and keto is generated and the other part is urea, and some of you probably know the name of this molecule. What is this name? What is the name of this molecule? Alloxan. It is a famous molecule, it is a classical name, alloxan. And what is this molecule? Uric acid. So, uric acid. So, that means uric acid was known long ago in 1800. So, then this is just a little bit of the history, you know, that means history, go back to 1934, if you take bone oil and do the dry distillation, what you get a molecule, all of you know what it is pyrrole. That means pyrrole was known since 1834. Then go to the next one, which you expect very similar distillations also produced pyridine, and I mean you can go on writing this thing that thing, but what I will say, I will write one more. In 1887 a molecule was synthesized, and thiazole was known since 1887. What does it mean? It means that heterocyclic compounds were known in the early days of organic chemistry. Early days, that means it is not, they are not the old molecules, they have been in the literature for a long time. Now you have to reorganize them, rationalize them. How do you do? How do you rationalize them? As I said before, Albert suggested that they should be classified as aliphatic heterocyclic compounds, aromatic heterocyclic compounds. Then that was not sufficient. I mean, it is too big, the classes are. So, what you have to do? Then they looked at the chemical reactivities. Many of you know, if aniline is reacted with potassium metal, what do you get? Right, good. So, potassium, you will get potassium salt, and potassium salt. Then if you treat this, let us say, with ethyl iodide, what do you expect? You expect this NH gets alkylated with ethyl, fine, and then if you further heat, what do you expect? Very good. So, that means it is predictable, and ethyl will migrate to this. So, exactly same way, if you look at this one, repeat the same sequence. So, I think all of us would agree that this would form potassium salt, then with ethyl so you will get this N ethyl, and then if you heat it you will get this ethyl migration to carbon. So, that means there is a parallel, there is a strong resemblance between this aniline and peptide. That was the noticeable parallel that has been noticed in early days. Likewise, many of you know that if you begin with nitrobenzene and boil with, let us say, sodium hydroxide at 70 degree centigrade. Any idea what could be the products or a product? One of the products is this 2-hydroxy nitrobenzene, 2-hydroxy nitrobenzene. That means basically hydrogen is displaced, I mean okay. Now, if you have very similar reaction with this sodium hydride sodium hydroxide and little, but this requires little high temperature though 250 degree centigrade, all of you know what is the product, right. What is the product? So, 2-pyridone. So, you see here that means the regular aromatic chemistry the regular aromatic chemistry will have very strong resemblance with this heterocyclic chemistry. Now, but there are two contrasting though. There are many of you know like pyrrole reacts with bromine very rapidly like aniline. Similarly, nitrobenzenes etc. They are undergoing this is nucleophilic addition, right. This is electrophilic additions, or you can say in this case heterocycles are nucleophile, in this case heterocycles are nucleophile on the top case, in this bottom case electrophile. That means there are two contrasting behaviors, and that has given rise to two very distinct nomenclatures. Now, many of you know one of them is known as pi electron deficient. That means with regard to the benzene molecule, so pi electron deficient. Pi electron deficient means those molecules which are electrophilic in nature. For example, pyridine and the corresponding 6 member with heterocycles. Okay. Then there are the molecules also known as pi electron. Well, the original word was little different though. This is pi electron excessive, pi excessive heterocycles. So, that means when do you rather get pi excessive and when do you get pi deficient. So, these are the two important. That means this is a very important clue though. That means whenever you reduce the ring size, pi electron density increases. So, that means 5 versus 6. That means what I meant to say, the ring size matters. That is important in the heterocyclic chemistry. Even as you go on proceeds classifying different heterocyclic molecules, even in nomenclature also, the ring size gets the preference in most cases. Okay. So, 6 member gets preference than the 7, and also you know now. So, these are the two important things as far as the chemistry is concerned, you have to remember. So, pi electron or sometimes say pi deficient and pi excessive, and like what she said is. Now, of course, when we study a subject, we have to justify ourselves that the topic is very important. Why the topic is very important? I think to start with, I said there are more than 50 million organic heterocyclic compounds are known in the literature today. Okay, 50 times 10 to the power 6 small molecules, it is a huge number. So, and of course, there are reasons then, that means obviously they must be important. So, what are the areas where I have a big list of molecules, I can go on writing, okay, if I have time I will keep on writing these structures, but if you go to the Google also, you will find that if you type a word, you will come up with the heterocyclic molecule descriptions, uses, preparations, and then toxicity, all these things. At the same time there is a structure. That means, if you are a chemist, then you should be able to be familiar with the structure and their structural features, that is very important. So, knowing structure, you can at least attach those molecules to different important areas. Important areas means like why they are so important in our day to day life. Okay. And in most cases see heterocyclic molecules are recognized as medicines, right. And then there are cases like say synthetic heterocycles which are also useful in in agriculture. There are herbicides, there are insecticides, and then of course, in addition to medicine and these things, there are a huge number of heterocyclic molecules which are used as dyes. I will show you some of these structures. Then other than that, they are used, their occurrence in vitamins, hormones, all other biomolecules, enzymes, cofactors, all these things. And lastly and what is it? Natural products, heterocyclic in natural products. This is the first kind of molecule though. This is by K.C. Mojumdar of Kolkata University, and fortunately I have a chapter also, but because of the limitations of the number of pages, so we could not write much about it, but it covers a whole range of natural products which features heterocyclic molecules, including epoxide, aziridine, oxytane, pyrrole, furan, pyran, pyridine, pyrimidine, all these classes, and lastly azipine. Azipine means 7-membered heterocycles. So, that means heterocyclic molecules are everywhere, including medicine, agricultural chemicals, dyes, these polymers, and then of course natural products. When I say natural products, that means there are some reasons why should it be taught or why should it be learned, this natural product heterocyclic compounds, because they are the molecules they give rise to the discovery of new drugs. Many of you probably do not know, morphine is one of the most rather strongest painkiller, right, strongest painkillers. When all the painkillers fail, the morphine is used, and all of you know morphine is grown by only specialized people or people with license, and like I cannot grow morphine in our garden, okay. And only because of that you cannot use it randomly, you have to, it has to be prescribed by a doctor. But today morphine has given rise to many simpler molecules, like you have known, I think I do not have to reiterate, quinine for example. What does it do? Quinine, these days people do not use quinine. What do you use? Huh? No, actually you use a simpler derivative. That like say in older time quinine as such used to be used as an antimalarial. Now people do not use it. They have found out that quinoline is the active part, the active pharmacophore. So, if you just do a little bit of the modification here and there, you may come up with this. And in fact, the chloroquine is a molecule, synthetic molecule though, is resembling the quinine. That means basically the quinoline part is resembling the quinine part, and so that is basically available in the market as an antimalarial. So, likewise that means there are plenty of examples where natural products can give rise to simpler version of the medicines. Okay. For example, I do not know whether you know, can you see this, do you see this structure, can you see what is it? I think by now you should be able to know. Okay. It is a 6-member ring, then an 8-member ring, then another 6-member ring, then an oxytocin ring here, and then on this side you have amino alcohol side chain. It is a natural products. It is a natural products. It has been obtained from a big yew tree, and it is called Taxol. So, anti-cancer. It is a very I mean useful anti-cancer. So, what I am trying to say that I mean there are plenty of justifications then why one should study heterocyclic chemistry. I mean I can as I said before, I can give you these structures from here and there. There are so many structures, all of them are useful though in our day to day life. Okay. But as a chemist, what should you learn? Little bit of chemistry. Okay. That means there are two aspects, academic aspect and commercial aspects, right. So, as an academician you must know the academic part. When I say academic part means what is it? Little bit of the structure, little bit of the chemical reactions, little bit of the synthesis. How do you go about the synthesis? So, that is I mean that means you have to basically identify the new chemistry while we talk about the different heterocyclic molecules. When I say new chemistry means I think again I am telling you a little bit of the physical properties, physiochemical properties and the reactions and the synthesis. Okay. And of course, industrial means you have to just see whether they are being used commercially and available in the market or not. Okay. When I say new chemistry, let me just tell you one or two examples probably that will suffice to illustrate the new chemistry. For example, if you begin with vinyl pyridine, and I think by now we know what it is. E2 means ethyl ester, so diethyl malonate and sodium ethoxide. So, what is the chemistry you can think about? Any guess? All of us know sodium ethoxide means diethyl malonate, it will form the corresponding anion here, right. What next? Addition. There are so many. Yes, fine. So, in this case that means in this case sort of a Michael addition. So, what you will be getting? You will be getting here so Michael addition. So, how did I visualize? That means you have to visualize this Michael addition. How did you expect this Michael addition? Because this carbon double bonded nitrogen has strong resemblance to carbonyl group. That means pyridine also has some resemblance with the carbonyl group, and because of this imine function, the adjacent alpha beta unsaturated double bond also is becoming electron deficient. So, the Michael addition is permitted. So, likewise there are for example, let me take you to another example. This is little different. Now, you have a pyrrole nucleus and a pyridine nucleus. You do reaction first with ethyl iodide, you get a compound, let us say A, and then you treat with sodium dithionite. That means, we are talking about the chemistry part, commercial utility etc. we have we will be talking a little later. Just to show you what could be the new chemistry, I will not write the structure. I think let us look at first the chemistry part. When I say chemistry means what should we learn about chemistry of heterocycles. So, in the previous case we have seen that Michael addition is taking place in a side chain, although it is not a typical alpha beta unsaturated ketone, but they behave like an alpha beta unsaturated ketone. So, similarly what should be the structure here? Now, if you understand the heterocyclic part, we have already said 6 member and a 5 member, there are two different, right. So, 5 member heterocycles are pi excessive and 6 member pi deficient. Now, tell me whether this ethyl group will go to which nucleus? 5 member, because electron excessive, right. So, that means I think, but that is the point, but you have proven to be wrong, because when I say, see, that is the thing, when I say pi excessive, actually what is actually what do you mean by that? Means the ring carbons are more electron rich than the corresponding benzene. So, our reference is always benzene. Okay. So, that is it, but at the same time you have a pyridine nitrogen which is also nucleophilic. In fact, this is what happening. So, you have to understand this. So, that is called chemistry. So, okay. So, typically if you let us say add pyridine to methyl iodide, leave it there for some time, just slowly N methyl compound would be forming. Okay. And that means this nucleophilic substitution is not taking place with ethyl iodide. Here it is this one, this, and this is A now. And what is the next thing? Of course, that means this part remains untouched, the other part is, so we guess, so Na2S2O4, what is the name of this molecule? Sodium dithionite, sodium dithionite, dithionite. What is it? It is a very good reducing agent, and quite frequently used in organic chemistry. And what you will be getting here, you will be getting this dihydropyridine system, So, that means I mean there are other examples, of course, as you will go on we will see in the next lecture. Actually I will talk about the effect of nitrogen. So, a nitrogen can alter the chemical reactivity of a particular organic compounds, and of course, in this heterocyclic compound, the heterocyclic compounds. Let us look at some of these important actually commercial molecules. Okay. And let us say what I will do, I will keep on writing structure. By doing so, I will instruct you to write the structures and recognizing the structures for some time. Okay. And on the way also we learn some of the usefulness of these organic molecules. For example, I think many of you know what is this, right? This molecule right, clavulanic acid. What is it? It is an antibiotic. It is a very powerful antibiotic though, very powerful and very useful antibiotic. So, it is an heterocyclic molecule. Now, okay. So, in this case what is it is not an aromatic heterocyclic, it is a non-aromatic heterocycle. Then there is a molecule, and let us say just some, that means we have to identify the basically the skeleton part, the substitution etc. all we are used to it. What is the skeleton? What is the heterocyclic skeleton here? One is beta-lactam, other is oxazoline. So, like say there is a molecule up here, I will write here, okay, that is known, this is known as, okay, this is 4 membered, then 7 membered here, and then you have a 5 membered. This molecule is known as varenicline, okay, whatever. So, but as for us we have to identify the structural features. What is the structural features? In this case, what is the nucleus? As you go on we will know more about the structures and the nomenclatures. What is this nucleus here? This nucleus 1,4-dinitrogen heterocycle 6 member pyrazine, 1,2 nitrogen pyridazine, 1,3 pyrimidine, 1,4 pyrazine. So, then we have also one more heterocyclic, non-aromatic heterocyclic. What is it? This is now what you see here, you have a 7-membered ring system. 7-membered ring system with nitrogen is known as azipine nucleus. Okay. So, this particular heterocycle is used for smoking cessation. Smoking cessation means those who are smoker, if you want to stop smoking, then you take this tablet, okay, and it helps. I can tell you that there for anti-smoking program, there are plenty of kinds of medicines available in the market. There are patches, right? There are chewing gums, there are injections, all kinds of things. I mean these days it is very easy to stop smoking by taking medicine, and one of them is this one. The other one it was in the news of the last week news. I said a little big molecule though, but it is worth knowing. It is a pyrimidine nucleus. Okay. Then it has a pyridine nucleus, then you have nitrogen NH, then one more benzene ring. Why I am writing, basically I am just trying to give you an impression about the different kinds of the structures, different kinds of the structures here, and to show the utility of the heterocyclic molecules. Then one more benzene ring, sorry, I think I will write here, this is a carbon. Okay. Okay. This is not. This molecule is known as imetinib, and commercial name is Glivec of Novartis. Okay. This was in the last week newspaper, and I have a newspaper cutting also here. Novartis loses Indian patent fight. Okay. Do you know, I guess this is an anti-cancer drug. This is a very popular anti-cancer drug, and this has been marketed by Novartis of Europe. Okay. But they used to have this drug before. Then in 1995, they introduced one more variety called beta Glivec, basically another crystal form, and they patented this because the previous one was to expire in 2015. By introducing another form, they increased the patent lifetime to 2019 or something like that. But then they went to this court and they lost it. What it is? It is an anti-cancer drug. Okay. They wanted to sell it as a beta form, in the sense that the other crystal form would be also as active as powerful, but this Supreme Court did not accept that these two forms are different. They are very similar to each other. Okay. But for us it is the heterocyclic molecule. It is the heterocyclic molecule that but you have to identify what are the nuclei. What are the nuclei? One pyridine, one pyrimidine, and the two benzene ring. That means without heterocycle the compound cannot be an active, and it is very powerful. It is nice medicine though, and people seek after this medicine quite frequently. And then the other part of this, you see here, one nitrogen, two nitrogens, and the two nitrogen. What is the name of this nucleus now? Previously I said piperazine, now. So that was the pyridazine, pyrazine. This is piperazine. This is saturated one. So it is piperazine. Okay. And then there are quite a few other medicine. For example, let us say I think we should little bit knowledgeable about this one. It is a very simple molecule. Very simple molecule. What it is? I think we should know all about it. From the structure you can find out, right? It is metronidazole. So metronidazole, ranitidine, Zintac, all these medicines actually they will have nice. Then I think lastly I will write one more. I think there are quite a few important structures. For example, okay, let us say from the field of medicine I will write one more structures. Do not worry about the number of the carbons here. There is a medicine which will have an amino acid part. I do not know whether you know or not. Then there is N-formyl. N-formyl here, and so like it is a carbon chain. Do not worry about the number of the carbon, you just go to these, and just if you remember the name you will find out the structure somewhere. early do you know what it is? Early state. Early state and so, but for us what is to be known? It is the heterocyclic nucleus. What is the nucleus? Nucleus is what is the nucleus? Nucleus is oxytocin. It is an oxytocin. Oxytocin or sometimes you can say beta lactone, not beta lactam, beta lactone. And early state actually is used for the treatment of obesity. Treatment of obesity. Obesity means all of you know, right? Putting on fats. So, likewise, and this is for the medicine part. Let us say this is there are a group of heterocyclic molecules also used extensively as herbicides and pesticides, insecticides. Okay. And some of them like that I will just write probably one here just to show you that this is chlorine though, chlorine and then sulfonamides. So, sulfonamides is a pretty important synonyms for herbicides, and so it's sulfonamides when you say so, or sometimes antipyretic or antibiotic. Sulfonamides, sulfur drugs. When a sulfur drugs, basically they are having the sulfone groups or sulfonamide groups and the corresponding heterocyclic nucleus, and they may be used as antibiotic, okay, and then painkiller, all these things. So, there are sulfonamides also, sulfonamide urea rather I should say, quite a few, but if it is attached to heterocycles, they could be also used as herbicide. So, likewise there are quite a few I think, and then I do not want to write let us say some other little bit of this. For example, all of us know, right, indigo, the structure. When I say in the chemistry class means just saying indigo is not enough. You in your mind you have to have the structure of what is the structure? Anybody? Let us say you have to, because your shirt color is blue, okay, blue. Everybody is wearing blue, so it is famous color, right? What is the structure? Okay. There are two kinds of molecules, by the way. There are two kinds of molecules. One is this, and see in heterocyclic chemistry actually what is this? This is 2 keto, this is 3 keto. Do you know the difference between the names? One is this is called oxindole and this is called no indoxyl, oxindole, indoxyl. So, and which nucleus is present in indigo, that is what you have to remember. If you can remember that is enough. The oxindole. So, oxindole, that means they are dimeric form of the this is dimeric form of the oxide. So, this is then there is a very important upcoming class of dyes, it is pretty famous now, what is called BODP dyes. They are an important class of fluorescent dyes, and structurally it is is a bipyridyl system, systems with double bond here and there, and then this is the basic unit BODP. Bo comes from boron or bora, and what is that dye? And DP means dipyridine, right? Dipyridyl, so you can say dipyridyl. Sorry, dipyrolide, dipyrolyl. So, dipyrrolyl, so bora dipyrrolyl groups. So, this this sort of molecules again are very useful and they are mostly this fluorescent dyes. Then there are, let us say, other dyes. I think this is quite well known in the market. It is a pyrazole nucleus, with an hydroxy on one side, and then you have an ester sodium salt on the other side on the ester, and there are two phenyl ring with sulfonate group. Oh sorry, this is double bond up here, and then just a repetition of these groups, and this is used by many as food dyes. It is a food dye, it is a food color. Actually, this color is used randomly in food dyes, and this is known as tetragen, right. So, tetragen, and then there are just I will write one more molecule, then I will go to the structure of this course. This is, for example, there is one more molecule here, it is a 5 member fused to a 6 member, 2 nitrogens here, and then pyrrole ring and this. It's such a small molecule. I mean, there are, I have a whole lot of structures, but I have selected few from medicines, agriculture, these dyes, and then this is again one of the safest food dyes used in the used commercially. Then this one, it is something little different. It is actually it is a flavor. It is a flavor of roasted meat. So, if you can synthesize this, that would give a flavor to the meat or the curry. Okay. And regarding the structure of this course, how do you, let us say, have you come across any books recently, heterocyclic book? Let us say, if you are assigned to teach in a college on heterocyclic chemistry, what book would you choose? Oh, that is important. RK Bansal, fine. Joule and Smith. Okay, I think Smith is gone now. Mills, right. Okay, fine. Then, okay, if you go and follow those books, you will be lost, because it is very difficult to cover all these all these aspects from the book in one semester, even in 2 semesters. You cannot really teach all. Heterocyclic chemistry is so intricate, because the complexity is so high. In fact, it is unpredictable, means there are so many mechanistic dichotomy, mechanistic possibilities. It is very, and unless and until you remember that this would give, as you will see the question paper, you will see I have given you questions from the textbook, but it is still difficult to work it out, okay, in the exam. Simply because at times you will see that nitrogen is a nucleophile attacking the carbonyl, sometimes it is attacking undergoing Michael addition, sometimes it does not doing is not taking part in reactions, just staying outside as a side chain. So, all kinds, that means that is difficult. So, that means, but books help. Of course, the book that you suggested, I think that should be the first book, that Joule and Mills, right. So, I think all of you know, I think I will just give you the rough name of this name all of you know, right, heterocyclic chemistry, and it is very recently it has been published as the edited version 2010. The previous one was I think 2005. So, after 5 years it has been again revised, and the book that also I would like you to go through, this is known as Eiser, T. Eiser. There are so many authors. I think I am just writing the first author. This also, the name of the book is the chemistry of heterocycles, okay. And then I will just write the authors. I think probably that would suffice to find out the exact name of the books. Then there is a book, there are actually 2 volumes by Lee, J. Lee, 2 volumes. these volumes are dedicated to only the name reactions in heterocyclic chemistry. Now, you can think about how these thick books are, and there are 2 volumes. So, you can think about how many name reactions are there in heterocyclic chemistry. So, you will be lost, really lost. So, do not I think I mean then there are, of course, there is a book here. If you are to see the natural products heterocyclic compounds, you can go to this one. There is a book by L.D. Quinn, but I will not suggest it to. This is not a good book though, although it has been published only very recently in 2010. Then I think there are other books, like many of you know the book by Gilchrist, T.L. Gilchrist, that is not followed. Then there is a book by Acheson, any idea? Okay. Acheson's book. Then I think this book could be a very useful one though. Packwaits, Leo Packwaits is a pretty famous organic chemist though, and he wrote this book long back in 1968, but I like this book. We grew with this book. It is a pretty useful book, easy to follow, and he was in heterocyclic chemistry to start with, but when people said heterocyclic chemistry is very easy and it does not bring you names and fames, then what he quit heterocyclic chemistry. He started doing only carbon chemistry, carbocyclic chemistry. But I think I will talk outside the class, but the carbocyclic chemistry defamed him. There are reasons, but the book he had written before was very good book. I mean this book is lying in our library. Then the other book that probably I will have you to look at, this is by Mayers, Albert Mayers, A.I. Mayers. This book is published in 1974. It is a new kind of book. It is a book, actually the name of the book, I think from there you can make out what is meant to be. It is actually named as a heterocycle in organic synthesis. That means let us say like what sort of molecule, let us say oxazole or isooxazole for example. If you treat with base, it opens up, it gives you cyanoketones. That means heterocycles are being used in the organic synthesis. Okay. So, these are there are so many other books, if you go to my website you can find out, but these are the main books. But for me I think the first 2 are the useful. Okay. And structurally how do I cover this whole topic? First we will do the introductions, then little bit of these structure determinations. It is very difficult though in heterocyclic chemistry, because you do not have many protons in the heterocyclic molecules. So, difficult to find out the structure. So, we will talk about that. Then effect of nitrogen, that means basically effect of heteroatom itself is good enough. If you can't locate and relocate or identify the effect of the nitrogens in the reactivities, and then you can master the heterocyclic chemistry very easily. So, that is a very important area, because nitrogen can do all kinds of wonders, right. It can stabilize the carbocations, it can stabilize the radical, it can assist the generation of the carbon ion, all kinds of things. Then it can assist the metallation, dematellations as well as transmetallations, all kind of you can do. Then there are some specialty reactions, like you have already seen that cycloaddition reactions. Then what is the other specialty reactions in heterocyclic chemistry? Multi-component reactions, many of you have that. You have multi-component reactions like Mannich reaction. The simplest example of multi-component reaction is the Mannich reactions. So, it can enter into the Mannich reactions and it can give rise to a variety of diverse range of the organic chemicals. Then what I have done also in this course, that I have devised the synthesis into 4 groups. When I say pyrrole groups, means all the 5 membered compounds with heteroatoms. Okay, like imidazoles, thiophene, etc., all these things. When I say pyridine group, means pyrimidines, pyrazines, all these things, okay, including quinolines. Then the next one, of course, this indole all of you know is a little special one, the benzene plus indole, pyrrole. So, it resembles strongly to pyrols, right. So, but there are some remarkable chemical features which are different from pyrrole itself. So, then of course, already it has been talked about called heterocyclic rearrangements we have talked about, that means a group of reactions are known which are to be categorized as heterocyclic rearrangements. Then since the then of course, there are other things, there are two important topics I have called building blocks and the reagents. There are plenty of molecules heteroatoms which can be used as reagents, ligands and catalyst like NHC etc., and then they can be also used building blocks. Building blocks means they can provide carbon, nitrogen necessary for other organic synthesis. And there are quite a few famous names we have already learned: cosmic, tosyl methyl isocyanide, as lactones they can be used, beta lactones, then cyanamides, urea, amines. Then there is a new group of lactams called Vince lactam. I do not know whether you have heard of it, Vince. If you go to the chemistry literature, this is Vince lactam. So, likewise there are a group, and then of course, I think others, when I say special topic, it can be also a special topic like say among the special topic what we have phosphorus heterocycles. Phosphorus heterocycles are also useful especially as ligands, many of you know. Then heterocyclic organic synthesis also is an important topic, like say furan for example, all of you know the furan reacts with benzene to form the corresponding bicyclic compounds, and they can be diverted to so many different kinds of structures, okay. And they have been made useful also in many total synthesis, okay. And then there is another aspect, of course, as an organic chemist one should know how to introduce say fluorine in an organic molecule. How do you do? Let us say you have an organic molecule, I said you introduction of fluorine atom in the substrate. How do you use fluorine? Of course, the fluorine cylinder is available, right, but the fluorine cylinder available and that is produced in only Russia, you have to import, you do not have anything here, and what do you do? And I do not know whether you have seen or not fluorine nuclear reactor. Fluorine reactors will have a special kind of the vessel that should be insensitive with fluorine, and the cylinder containing fluorine will have only 1% or 2% fluorine diluted with something else, I have forgotten, I think it could be nitrogen probably, or sorry oxygen probably, oxygen and fluorine mixed together, and only few percent is fluorine. That is good enough as a source of fluorine. And other than that, what are the other fluorine source? Trifluoroacetic acid, this thing, that thing. So, that means trifluoromethyl group is a very important structural moiety that can be used as the introduction of fluorine. What else? HF, very good, HF, and then there are reagents like PPH, that pyridine HF complex, and then so this is actually important area all of us know, because the introduction of fluorine actually improves medicinal properties of many drugs, okay.